Day 2. It says the population of a city is expected to increase by 7.5 next year. If P represents the current population, which expression represents the expected population next year? So remember, it is an increase, I-N-C-R-E-A-S-E. So we're adding that population to what we already have. So if the current population is 100%, and we're adding 7.5, so remember this as a decimal would be 0.075. So which one of those would work? Okay, so we know it's not A because that says 1.75. Sorry, I'm trying to get attendance because people are coming in late.
C.
So C. Okay, so can we add this and this together?
Yes.
We can. Does this have a P? So remember, if we're increasing, so let's say my population is 1,000 and we are increasing by 0.075, right? All right, so this is just an example, right? So if we go back and let 1,000 be X, we're going to multiply this times that. So I'm going to get 0.075x. Then since it's an increase, I have to add it back to that 100%. And actually I should have used P because that's what they use as P. So let's go back and put P. Okay, so that means this should have had a P with it. So I can't add this one because it doesn't have a P. So the only other one that I can add, if this is 1P plus 0.75P, it would have to be what? B. That is correct. That is correct, Samir. B. So your correct answer would be B. Okay? All right. So what you guys should be working on today is the review for your test tomorrow. On Thursday. Because remember, tomorrow we're going to do the FSA day. Okay, so the review is on page 411. 411. All right, so let me make sure that I have everybody that has came in late. All right, so I see Terry on, yeah. Do not see Zoo Angelique. Lawrence, do I see a Lawrence? Nope. What about Jakira? Yeah. What about Taylor? No. What about Noah? No Noah. What about Isaiah? No Isaiah. All right, and what about Kamari? Is he here? No, still no Kamari. All right, so we will go over the answers to the review in about 25 minutes. Okay? Remember, no vocabulary. And so 25 minutes, and then we will go over the answers. The page number is 411. 411. Of all the audience members. All right, so VIP seats are the smallest. Balcony is the next, right? And then the main floor is the largest. So if we look at our choices, we know that C definitely cannot work because they should not be equal on our sample. 20, 20, 20. Because this is 100, this is 400, this is 700. All right, so on A, balcony, who is the second smallest, has more than the main floor. Well, so we know that one can't work. If you go and look at D, VIP seats, which is 10, is higher than the main floor. Well, that can't happen either. So due to process of elimination, it has to be B. 5, 35, balcony being the second. Okay? All right, number 5. There are 580 students at Alejandro's school. He surveys a random sample of 60 students and finds that 21 of them regularly bring their lunch. Based on the results, estimate how many students at Alejandro's school regularly bring their lunch. State what strategy and tool you will use to answer the question, explain your choice, and then find the answer. All right, so my sample is 60 students, and 21 of them said they bring their lunch. So 21 over 60. Okay, so we could simplify it, right? So I could say that 21 divided by 3 is 7, and 60 divided by 3 is 20. So basically, by scaling down, I now can figure out maybe the percentage if I wanted to, right? So if I do that, I could scale it up to 100. So that is times 5. So even though it didn't ask me for a percent, we can find the percent. So 35% of the people said that they bring their lunch. So we could take that 580 and I can multiply it by that decimal equivalent. So 580 times 0.35, and I would get 203 people. Okay, so that is one strategy, is find the percent. Okay, is that the only way to do it? No. The other way is we could do a proportion, right? So I could say 21 divided by 60 equals X over 580. Then I could say, well, how many times does 60 go into 580? And it gives me that nice repeating decimal. Okay, so that would be 9 point. Okay, so what I would do is I would leave that in your calculator and I would multiply that times 21 and we will get 203. Okay, so either method works. So find the percent, multiply it by the percent, or the second way is proportion. A proportional relationship. Okay, so two different ways to solve the same problem. Okay, so let me pause for a second and give those of you that are copying a little bit of time to copy. Okay, does anybody need more time to copy? All right, I'm not hearing anything, so I'm going to flip it over. All right, 6 says, a city librarian wants to see if visitors want to add a cafe to the library. On Monday morning, the library surveys every 4th visitor to the library. Is this likely to be a representation of all library visitors? Okay, so the information is they're doing it on a Monday morning, but we want to know what all librarian visitors want. So, is it a likely representation? The answer is no. And it is because on Monday morning, you would not get students, right, like yourself, that go to the library, or people at work. So that is not a good representation, because you would only get people basically who have the day off or who don't work to make some decisions about all your library visitors. All right, number 7, a factory produces 4,800 pens. The company dictates that if a random sample of the batch shows that more than 2% of the pens are defective, the batch needs additional testing. A worker checks a random sample of 60 pens from the batch and finds that 2 are defective. Based on this information, which statement about the sample is true? Select all that apply. All right, so we know that 2 out of 60 are defective. Okay, so if I find the percent, right, so if I do 2 divided by 60, I get 0.0, and it's a repeating decimal. So it is about 3.3% that are defective. Okay? It says over 2%, we're going to throw it away, right? It needs additional testing. So if it's over 2%, it needs additional testing. So we have 3.3. So definitely A, it needs additional testing. So it says it indicates the probability that about 96 pens in the batch are defective. Well, we have 4,800. If we multiply that times 3.3%, right? So I can put that in a calculator. So 4,800 times 0.033, I get about 158. So 158 are defective out of 4,800. Okay, so we know that one doesn't work. So this one says indicate there is probably about 650 defective pens. I would say yes, because
I did the fraction method and I hit exactly 160.
Right. Right. If we would have scaled it up, we would have gotten 160. Because of this repeating decimal, guys, it causes the number to be off. So if I would have taken 2 divided by 60 and leave all of these numbers here and then multiply it by 4,800, I would get 160. Okay? So repeating decimals are tricky because it depends on how you round to depend on what answer you're going to get. Okay? So what I would do is when you find that percent, I would leave all of those numbers in your calculator. Then go back and take it and multiply it by that original number. And you would get 160. So definitely C. Okay? So indicates probably about 4,580 pins in the batch have no defects. Well, we would need to take 480 and minus 160. So 4,800 minus 160 is 4,640, not 4,580. Indicates that about 1.2% of the pins are defective. Well, we already know it's 3.3. Okay, so cross that out. All right, number 8. We're running out of time. A company makes short sleeve and long sleeve t-shirts. The company checks a random sample of 60 t-shirts of each type and finds that 4 sleeve shirts have problems and 1 long sleeve shirt has problems. How many t-shirts does the company predict to have problems in a shipment of 3,000 shirts of each type? All right, so the total that are defective are 5 out of 60. Okay, so we could do, like Ms. Capel said, we could do the ratio method. Okay, so if I do 3,000 divided by 60, I get 50. So this would be times 50. So then 5 times 50 is 250. So we could expect 250. If you want to do the percent method, then once again, it's a nasty percent, right? So leave that there. Multiply it by 3,000. And we would get 250. Okay, so either way, you would get that answer. All right, number 9. An inspector, it takes 20 different random samples of 25 apples from the shipment of 2,000. Based on the data, what is the most reasonable prediction of the number of apples this shipment that weighs more than 7 ounces? All right, so 129 over 500. So what I did was I added each value of this. So this would be a 3, a 4, a 10, a 36, a 42, a 24, and a 10. So I added all those up to get 129 out of 500. Okay? We know that there are 2,000 apples. So this would be times 4 times 4. So 129 times 4 is 516. So that is about 520 apples. Okay? All right, and then the last one says, Karen and Zeb each use a computer program to randomly select 50 students from the school directory. They ask the students about school rules. They find 68% from Karen's sample and 72% from Zeb's sample say the rules are fair. Explain why Karen and Zeb likely got different results even though they used the same sampling method. Okay? So we know, guys, you could do another sample and get a different result, right? So even though the findings are similar, there is likely to be variation in the actual results. Right? So we learned that. We could do 15 different random samples and we will probably never get 3 or 4 that are the same. They will always be different. Okay? Okay? So these samples are also representative of the groups. Okay? So sample is a good representation SEN of the group. Okay? All right, so that is the end. So tomorrow is the FSA review day. So we will do that tomorrow, and then you will take your test on Thursday. If you are here to take the FSA writing on Thursday, it's okay. The test, you'll just take the test on Friday. Okay? All right, guys, have a good day.